Okay, so in this module, we're going to go over solving equations. So here is just an introduction into solving equations. Right now, our previous formulation, we've been dealing with functions, right, where we define f of x, as you see here in our Desmos screen in front of you, equals sine of x, or y is equal to sine of x. Right, both of those formulations, as you can see, they represent the same thing. Right, so that is our function formulation, right? F of x equals sine of x. Right, our function has one input, right, the input x, and it gives some output y, which we call f of x. All right, now we're going to switch that up where we're going to look at something that is more of the form that looks like this, right? Sine of x equals 2 square root of 3 over 2. Now this is an equation, right? Now this is asking something different. This is saying for what values of x does the sine of x equal to root 3 over 2? Right? Now, we can think of it as our function notation where we say, okay, well, I can think of each one of those expressions on the side of the equal sign, on the right side and the left side, as two different functions. Right? One of them being square root of 3 over 2, and the other one being sine of x. Right? Now, the sine of x you see in front of you right there. Right? It's our sinusoidal graph, excuse me. Right? And you want to kind of ask ourselves, all right, well, what if I had y equals to square root of 3 over 2? All right, let me adjust our window here. Okay, so there we go, right? Now, when we think of it in terms of this formulation, right, when are they equal to each other in terms of the graphs? When do they intersect? Right? And here we see, all right, well, those are 4 solutions, but in fact, we actually know there are a lot more than 4 solutions. There's 2 more, there's 6. We know there's a lot more of them, right, because this sign is periodic, right? The sinusoidal graph is periodic, right? And in fact, every time they touch, they intersect, that's another solution to the graph. All right, so when we simply ask when the sine of x equal to root 3 over 2, well, that is going to require an infinite number of solutions, right? Or there is an infinite number of solutions, excuse me, right? Now, in certain cases, right, and we'll learn how to find all of those solutions, right? We're not going to write those out, right, because we can't write down an infinite number of solutions, correct? Uh, but in some cases, we can use some kind of equation that'll represent an infinite number of solutions, and we'll go over how to do that. Right? Now, in some cases, we'll be asked to simply find in a given interval. Right? Right, so what I mean by that is, well, what if I don't want to find all the solutions, right? What if I simply want to restrict my domain, right, to be, let's say, between 0 and 2 pi? Get rid of this one for now. Okay, and that's what we see here, right? What we see here is this is the graph between 0 and 2 pi. That's my restricted domain, and I want to find all the solutions there. And in this case, there is a finite number of solutions. There's pi over 3 and 2 pi over 3. Okay, and we can list those out, right? Those are the solutions in that given interval, or really any interval that we're kind of asked to find solutions for. Okay, so in this section we will go over the different processes to find these solutions, whether it be across the whole domain or some restricted domain like we have here. All right, and we will do these. Here's a nice demonstration graphically, but we will be doing these analytically, and we'll go over them using algebra techniques and stuff like that, depending on how involved the equation is.